So AI, machine learning, Gen AI. I mean, you hear these terms thrown around everywhere, right? From the news to your social media feed. But what's the actual difference? How do they all connect? It can feel like you're trying to solve a puzzle without the picture on the box. Well, in this explainer, we're going to put that puzzle together, piece by piece. My goal is to give you a super clear, simple picture of how this whole thing works.
Okay, so here's our game plan. First, we'll tackle the big ideas, clearing up what AI, ML, and Gen AI actually are. Then, we'll dive right into the heart of it all, data. It's the fuel that powers everything. We'll look at how different kinds of data shape how machines learn. We'll follow the entire process from just an idea to a finished model, and then wrap it all up by connecting these concepts to the real-world tools that bring them to life. All right, let's jump right in. Section 1, AI, ML, and Gen AI. Look, before we can get into the real nuts and bolts, we've got to be speaking the same language. So let's start by untangling these buzzwords that are everywhere and really get a handle on the big picture and how they all fit together.
This really is the core question, isn't it? I mean, these terms get thrown around so much, they start to sound like they all mean the same thing. But they don't. Not at all. They're actually layers of the same idea, with each one building on the last. So let's break it down.
Okay, first up, artificial intelligence, or AI. You got to think of this as the huge, giant umbrella. It's the whole field, the big dream of making machines smart, getting them to learn, reason, and solve problems. Kind of like humans do. It's the ultimate goal. Okay, so tucked right inside that big AI umbrella, you've got machine learning, or ML. Now think of ML as a specific approach to getting to that AI goal. Instead of a programmer sitting there and writing code for every single possible scenario, which would be impossible, right? ML lets the machine figure out the rules for itself. And how does it do that? By learning from data. And that's the absolute key here. Data is the teacher.
And then, you've got the one that's been a total game changer lately, Generative AI. This is a really specialized type of machine learning. It doesn't just, say, analyze data or predict something. No, it goes a step further. It actually uses everything it's learned to create something totally new, something that didn't exist before. We're talking images, text, music, you name it.
So, there you have it. This lays it out perfectly. You see how it works? AI is the whole universe. Machine learning is a galaxy within that universe, and generative AI is like a star system inside that galaxy. They just nest inside each other, each one getting more and more specific.
And this analogy is just fantastic because it really gets to the heart of what makes Gen AI so special. Think about it. A regular model might learn to recognize a painting by Picasso, but a generative model, it studies thousands of paintings, learns the underlying styles, the brushstrokes, the patterns, and then it can create its own totally new piece of art. It's the difference between recognizing and creating.
Okay, so we've established that data is the teacher, right? Well, that brings us to a super critical point. If the teacher has its facts wrong, the student is going to learn the wrong things. It's that simple. Data is the absolute foundation of all of this, and its quality, well, that determines everything. And this analogy about the mislabeled animal book nails it. I mean, this is exactly why it's so critical. If you feed your model bad, messy, incorrect data, you're going to get a bad model. It's the classic garbage in, garbage out rule. It'll learn all the wrong patterns and, you guessed it, make totally useless predictions.
So what does high-quality data actually mean? Well, it pretty much boils down to these 5 key things. You got to ask yourself, 1, is it accurate? Are there errors in here? 2, is it complete? Do we have enough of it for the model to actually learn anything useful? 3, is it representative? Does it actually reflect the real world, or is it biased? 4, is it consistent? Is everything in a nice, uniform format? And finally, number 5, is it even relevant to the problem we're trying to solve in the first place?
Okay, so we've established we need high-quality data. Check. But here's the thing. Data isn't a one-size-fits-all deal. It comes in all sorts of different shapes and forms. And the type of data you have is like a blueprint. It basically dictates the entire approach you're going to take to build your model.
For the most part, you can split data into 2 big camps. On one side, you've got structured data. This is the nice, neat, tidy stuff. Think spreadsheets, databases, everything in perfect rows and columns, like a list of customer orders with the ID and the cost. Super organized. On the other side, unstructured data. And that's, well, it's everything else. It's the messy, chaotic stuff of the real world. Emails, photos, videos, social media posts. No neat columns there.
Now, within those 2 camps, there's another really important distinction. Is the data labeled or unlabeled? Labeled data is exactly what it sounds like. Someone, or something, has gone through and added tags that give it meaning. So this image gets the label cat. This customer review gets the label positive. Unlabeled data is just the opposite. It's just a huge pile of raw stuff. Say, a folder with a million photos and no descriptions. And this difference, it's absolutely crucial for what we're about to talk about.
See, this is why that matters so much. If you have that nice, neat, labeled data, you get to use a method called supervised learning. The best way to think about it is like giving the model a giant stack of flashcards for a test. You've got the question on the front and the correct answer on the back. The model just churns through thousands of these, learning the relationship between the question and the answer, so that when you give it a new question it's never seen before, it can make a really good guess at the answer.
But what if you don't have the answer key? What if all you have is that big, messy pile of unlabeled data? Well, that's where unsupervised learning comes into play. Here, you just hand the model all that data and basically say, go find something interesting. It's like detective work. The model sifts through everything on its own to find hidden patterns or natural groupings. Maybe it discovers you have 3 distinct types of customers you never even knew about.
And then there's the third type, reinforcement learning, which is a totally different beast. This one is all about learning from trial and error. Honestly, the best analogy is training a dog. When it does the right thing, you give it a treat, a reward. When it does the wrong thing, you don't. The model works the same way. It tries something, gets positive or negative feedback, and over millions of tries, it learns the absolute best way to achieve its goal.
So this table just puts it all together nicely. Supervised, that's when you have labels and you're predicting something, like housing prices. Unsupervised, that's when you have no labels and you're finding hidden groups, like customer segments. And reinforcement, that's learning from rewards and punishments, which is perfect for complex tasks like training a self-driving car.
All right, we've covered the big ideas, the different types of data, the learning methods, all the essential building blocks. So now let's put it all together and see how this works in the real world. We're going to walk through the machine learning lifecycle. Think of it as the factory assembly line that takes you all the way from a raw idea to a real-world result.
This whole process usually breaks down into 5 main stages. Step 1, gather. You've got to collect all your raw data from wherever it lives. Step 2, prepare. This is maybe the most important and time-consuming part. Cleaning the data, fixing errors, getting it into a usable format. Step 3, train. You feed that nice, clean data to your model and let it learn. Step 4, deploy. You take your trained model and put it out into the world where it can actually start doing its job. And finally, step 5, and this is crucial, manage. You don't just walk away. You have to monitor its performance, make sure it's still accurate, and keep it updated over time.
Okay, I know that 5-step lifecycle can still feel a little abstract. So let's make it super concrete. We're going to look at how a modern platform, like Google Cloud, actually has specific tools designed to help you with every single one of those stages. And check this out. This is how it all maps together. For that first gather stage, you've got tools like cloud storage, perfect for just pulling in all that raw data. Then for the prepare stage, you use something powerful like BigQuery to do all that cleaning and organizing. The real magic, the training and deploying, that happens in a central hub like Vertex AI. And for that final manage stage, you use automation tools like pipelines to make sure everything keeps running perfectly. You see? There's a specific tool for each job, creating this smooth workflow all the way from messy data to a real-world solution.
So there we have it. We've journeyed all the way from the big, fuzzy concept of AI down to the specific tools you can use to build, deploy, and manage a real machine learning model. The path from data to deployment isn't a mystery anymore, is it? It's a clear, structured roadmap. So I guess the only question left for you is, what problem are you going to solve first?